Good evening, everybody. It's Wednesday, I believe, 8th of April, and this is Nighttime Mathematics Radio. I'm afraid we're going to have to live without the cheesy clips today, but for the moment, this will be Nighttime Mathematics Radio. The show works the same way every time. All you have to do is tweet your questions here to @NightMathRadio on Twitter, and I'll try to answer them live on the air. For the moment, I do have one question going right off the bat. It turns out an old high school friend of mine tweeted some questions to keep everyone entertained during the apocalypse here. So let's take a look at this one. Now this is a pure geometry problem. Looks like this. It says, we have some rectangle. Which has two circles in it. You've got a quarter circle of some radius, which takes up some piece of this rectangle. Oops, so good for it. And then you have a half circle, which takes you to the end of the rectangle. And the tangent line, oops, that's not a very good tangent line. The tangent line to the circle here is 5 centimeters long. To the tangent point. So the question is, what's the area of the rectangle? And so this is a wonderful open-ended question. The question is, well, what do we do? Nothing's defined. All we know is that we've got one 5 centimeter length, which isn't even anything to do with the rectangle. It's this weird tangent line that comes from a corner of the rectangle and goes off to this half circle. So how do we do this problem? How do we even get started? The answer is, let's start by defining some variables. It's hard to even talk about this problem if you don't have your variables defined. What do we have? We have two parts of circles. We have a big quarter circle here. So I'll give that radius capital R. Capital R because it's big. And the smaller circle here, I'll give radius lowercase r because it's smaller. And the cool thing is, just like that, by writing down two variable names, we can now write down an expression for the area of the rectangle. How? Well, if that's the radius, so is this. After all, circles only have one radius. And here we have two little radii. So we now can write down an expression of the area of the rectangle. The area of the rectangle is, as always, base times height. The height is r, and the base is r plus 2r. So this is r squared plus 2rr. Now what do we do? Well, we use a trick. We know something about tangent lines to circles. And the thing we know is the tangent line to the circle makes a right angle with the radii of the circle hitting the same point. So we take that radii there. This is radius r. This one we know is 5 centimeters. And now we've got a cool right triangle here that we know all three sides of. We know one short side is length r, another short side is length 5 centimeters, and the long side is length capital R plus lowercase r. And we can use Pythagoras' theorem, because after all, short side squared plus other short side squared equals long side squared. So 5 centimeters squared plus the small radius squared must be equal to the long side squared. And what is the long side? You can see it there. It's little r plus big R. And now we can square out this side. We can just use FOIL, do it mentally. This is 25 square centimeters. Because remember, when you square centimeters, you get square centimeters. You get an area, which is good. Plus lowercase r squared is equal to lowercase r squared plus 2r capital R plus capital R squared. And now we look at this expression and go, wait a minute. I recognize this bit. That's the area. It's right up here. So we subtract r squared from both sides, and what we get is 25 square centimeters is equal to the area. Done. This is an incredibly cute problem. Because you notice everything falls right out as soon as you define your variables. This is actually the most important step in any word problem and any geometric problem. Before you do any work at all, make sure you've got good names for your variables, make sure you're going to remember what they mean, make sure you've drawn the picture. Because if you haven't done that, the problem's going to be almost impossible to do, no matter how easy it actually ends up being. This is Nighttime Mathematics Radio. Well, for the moment, as I say, we're a little short of music here to support the show. I could probably throw something together, give it a bit of time. But for the moment, let's see if Twitter has anything interesting to say. If not, this could be a short show. Let's see. So far, no one's asked any questions on Twitter. They post a link to the show so you can. So ask math questions on Twitter. And I'll answer live on the air. So once again, this is Nighttime Mathematics Radio. This show's on nightly from 9 p.m. until we run out of questions. That can be as long or short as it takes. The show can be as short as 10 minutes long as an hour, depending how much people are asking. Right now, things look pretty quiet, so it's going to end up being a short show. But that's okay. A day where everybody more or less understands the calculus is a good day. Or the algebra, the trigonometry, the pre-calc, the linear algebra. Whatever you're stuck on, if you're not stuck on it, you're having a very nice day. All right, everybody. Well, things are looking a little quiet tonight, so may end things very early. Well, things are looking quiet, so I'll probably end the show quite early here tonight. This is Nighttime Mathematics Radio. This is a show where you can ask your questions live on the air. We'll try to answer them. You ask your questions on Twitter by tweeting them to @NightMathRadio. And please be specific, because I can answer a really specific question like the one I worked earlier. If you tweet something like, I don't understand pre-calculus, I'm not able to say much more than, I'm so sorry. But if you tweet, I can't do this problem, and tweet me a picture of it, then I can really do something. I can actually talk to you how to do the problem. And I can talk about the problem, too, try to give you some sense of how the problem works. So that's really how the show's meant to work. This isn't really meant to be just I can't do pre-calculus, because I can't say much more than, that's a shame. Well, as I say, let's take one last look at Twitter, see if anything's come in. Looks like a quiet night. All right, everybody. Well, in this weird world where the classes have all stopped, but the homework just keeps going on and on and on, tune in anytime you're feeling some stress about your math classes and just need a little bit of help. This has been Nighttime Mathematics Radio. Good night, everybody. Stay safe and keep doing the math.